All right, this lesson is on variation. There are two main types of variation. The first one is direct. I can spell that correctly. Direct variation. Y varies directly with X. When you see that, that means that Y equals some number K times X. K is a number, it's called the variation constant. Variation constant. Okay, and an example of that would be, they're all over the place actually. Let's say that you make $8 an hour at your job, and $8 an hour, and you work H number of hours. Then the amount of money you're going to get is going to be your 8 times H, your salary. Salary for S equals 8 times H, excluding taxes and that sort of thing, of course. But this is just a simple example of direct variation out there. Instead of a Y, you have an S. Instead of a H, you have an X. These are your variables, and the variation constant is 8. The other type of variation is inverse variation. Inverse variation. Y varies inversely with X. Inversely with X. Now, inverse variation is not Y equals K times X. It is Y equals K divided by X. Okay, so keep in mind, when it says direct, it's K times X. When it's inverse, it is K divided by X. That's the difference between the two. A good example of inverse variation out there in the world would be if you are renting an apartment and you have roommates. Let's say that you have an apartment where the rent is $1,200, and you have 4 roommates. Let's say n equals 4. Number of people in the house is 4. Then the rent that each person would have to pay would be $1,200 divided by 4. Each person would have to pay $300. If, on the other hand, there were only 3 people, then each person would have to pay more rent. They'd have to pay $1,200 divided by 3. They have to pay $400 each. So in general, the amount of rent that each person would have to pay would be $1,200 divided by the number of roommates. And notice that it's division. It's K, there's my K right there, over the variable n. So that's inverse variation. Okay, let's do another an example of direct variation here. Let's say we have W varies directly with X, and we also know if W equals 8 when X equals 2, find W when X equals 20. Okay. We need an equation to write down here. W varies directly with X. So instead of a Y, I have a W here. W varies directly. Remember, that means K times X. W varies directly with X. Now, you can't really answer the question until you figure out what K is. So the next thing I got to do is find K, the variation constant. And in order to do that, I plug in the extra information they always give you. And here it is right here. When W is 8, X is 2. Plug in the 8 for the W, plug in the 2 for the X, and if I divide, that tells me that K equals 4. I found the variation constant, it's 4. And so this equation is actually W equals 4X, right there. That's our direct variation equation. Our variation constant is 4 here. Now I can use that equation to answer the question right here. Find W when x is 20? Well, if x is 20, then w will be 80. The answer is 80. By the way, direct variation is the same as directly proportional to. You could set up a proportion to solve these direct variation problems, but since the book solves it this way, I'm going to do it this way as well. All right, moving along. Let's say we have r varies inversely with t. And if r equals 8 when t equals 2, find r when t equals 10. Okay. Let's write down our equation here that applies. R varies inversely with t. Inverse variation. So r varies inversely. It's going to be k divided by something. K divided by t. Now I got to find the variation constant k. So I'm going to use this extra information right here. When r is 8, t is 2. Plug those in. Multiply both sides of the equation by 2. K here is 16. K is 16. So this equation, this inverse variation equation, is actually r equals 16 over t. There we go. That's the equation I have to use to answer the question. So let's answer it. Find r when t is 10. Well, if t is 10, then r is 16 over 10, which I guess you could reduce if you want, which would be, divide by 2, 8 over 5. R is 8/5. There it is. Okay, so there's a difference between direct variation and inverse variation. Let's do now some examples that are more applicable to the real world, I guess you could say. The distance a spring will stretch is directly proportional to the force applied. Now we got to get an equation out of this, and here's how we do it. The distance is directly proportional to the force. So I'll use d for distance. Directly proportional means k times force, F for force. I've got my equation. Directly proportional, direct variation. Just like the other problems, you must now find the variation constant k. So I pick out the extra information they give me here. When the force is 150, the stretch or the distance is 8. So I'm going to plug that in here. Distance is 8. Force is 150. Now if I divide both sides by 150, oops, I didn't want to do that. The k is 8 over 150, and I think I'll leave that as a fraction. That's if I reduce that, that's going to be 4 over 75. I don't think that, no, that doesn't reduce any further. So there's my variation constant k, 4 over 75. So this equation is actually d equals 4 over 75 times f. That is the equation which I need to use to solve the problem. So how much will a force of 400 newtons stretch the spring? Plug in the 400 for f, like that. That's 1600 over 75, and if you take out your calculator and divide, have it divide for you, you end up with, let's see. I got my calculator right here. 1600 divided by 75 is 21 1/3 centimeters. Make sure that you include the units if it has one. Okay, and we've solved our problem. Direct variation problem. I believe we have another one. Yes. Okay, let's come up with an equation from this. The distance, d, an object falls, varies directly, so it's going to be k times something again, direct variation. What does it vary directly with? Square of the amount of time it falls. Not varies directly with time, t, but it varies directly with the square of the time, t squared. See that right there? Square of time, so you got to put a little square on there. That's the equation we need. D equals k times t squared. Now just like the other problems, I now have to find k. So let's see here. If a skydiver falls 64 feet in 2 seconds, I can use that information to find k. Let's plug it in. 64 feet time 2 seconds. Don't forget to square it up there. 64 equals k times 4. Divide, and k is 16. My variation constant is 16, and so that tells me that this equation is actually d equals 16t squared. Let's use this to answer the question now. How far will the skydiver fall in 8 seconds? In 8 seconds, the distance will be 16 times 8 squared, and if you multiply all that together, I believe that is 1,024. And that's a distance, so that's going to be, is that feet here? Yeah, feet. 1,024 feet. Okay. So notice the difference between this one and the previous problem. Here it was square of time, so I had to put that little 2 there. You could have cubes and fourth powers and so on. I think we see one of those a little later. Moving on. Volume varies inversely. So V for volume varies inversely means k divided by, if you recall, inverse variation. Varies inversely with pressure, so I'll use P for pressure. So our equation is V equals k over P. I'm now going to find k by plugging in the extra information. When the volume is 10, the pressure is 6. Volume 10, pressure 6. Multiply both sides by 6 there, and you get k is 60. Remember, you got to multiply both sides by 6 like that. Cancels. K is 60. So this equation is actually V equals 60 over P. Inverse variation equation. Let's use it to answer the question. What's the volume when the pressure is 12? The volume when the pressure is 12, plug in a 12 for the P there, the volume looks like will be 5. 60 divided by 12. What's the units for this? Volume, cubic centimeters it says up there. Volume equals 5 cubic centimeters. Okay, so there's an example of inverse variation. Let's see if we have another. Yes. Oh, I remember this one. This is the one that I typed in incorrectly. It should say this. Force with which objects attract each other varies inversely with the, write this in, square of the distance between them. If I remember my physics, it's the square of the distance. Okay, so let's set up our equation here correctly. Force, F for force, varies inversely, so that's going to be k divided by. It's supposed to be varies inversely with the square of the distance. Square of the distance, so that's going to be d squared. Okay. This one is probably in your homework set somewhere. It should be square of distance. Okay, let's find k. So I got to plug in this extra information right here. When the distance is 4,000 miles, the force is 160 pounds. So 160 goes there. The distance is 4,000. Don't forget to square it. Got a little square there. And if you, well, that's going to be a big number. If you solve for k, you get times 160, wow, 256 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. 2,560,000,000 is our k, large number. If you wanted, if you recall, scientific notation, you could write it as 2.56 times 10 to the 9th. But you don't have to. Well, that's what it is in scientific notation. Okay, so this equation is F equals K, 2, 5, 6, 0, 1, 2, 3, 4, 5, 6, over d squared. That's a big variation constant. Let's now solve the question, solve the problem. Find the force when the object is 6,000 miles from Earth. So the distance is 6,000. 2, 5, 6, 0, 0, 0, 0, 0, 0, 0 over 6,000. You got to square it. Remember the square right there. And if I type that in my calculator, let's see what we come up with here. 71 and 1/9, and that's in pounds. 71 and 1/9 pounds is our answer. All right, so there's another example of inverse variation, and this one was inverse variation with the square. I believe we have one more example. The maximum load, so L for load, the maximum load for a column varies directly, so that's K times, if you recall. What does it vary directly with? 4th power of the diameter. The 4th power of the diameter, so that's going to be d to the 4th. And inversely, so it's 2. This is called joint variation. The book was called it joint variation. So, and inversely, so it's going to also be divided by the square of the height. So that's h squared. This is the equation we have to work with. Okay, we got to find k. So let's plug in this extra information they give me here. A 9-meter column, I think that's the height, 1 meter in diameter, will support 8 metric tons. Let's plug all those numbers in. The load is 8 tons. The diameter is 1 to the 4th power. Height is 9, and you got to square that. If we solve this for k, we end up with 648 for k. All right, so our equation here is actually L equals 648 d to the 4th over h squared. This is actually a joint variation. It has direct variation and inverse variation at the same time, combined. Okay, let's say answer the question. How much will a column 12 meters high and 2/3 of a meter in diameter support? So let's plug those numbers in. 648. The diameter is 2/3. You got to raise it to the 4th power over 12, and you got to square it. 648. 2/3 to the 4th power is 16 over 81. And if you divide by 12 squared, that's really the same as multiplying by 1 over 12 squared, which is 1 over 144. And you could use a calculator to help you with this if you want, or you could reduce your fractions by yourself if you are inclined. But it should work out to be, as a fraction, reduced to 8/9, and that's the support, so that's going to be metric tons. 8/9 of a metric ton. And there's our example on joint variation. Okay, so now you should know how to solve problems using direct variation, inverse variation, and joint variation. And that concludes the lesson.